Hi, my name is Dario, and I'm making this session in preparation for a talk that I'm giving on upcoming React features at React Dublin next week. And we'll be exploring then how features like hooks and suspense can, and if they can help us build apps better. And for that, I figured I needed an app to get started with, because it might be easier to see the effect of all these different bits when they're actually applied to some application. So for that I borrow an app that a friend of mine, Amy, did, which is Minesweeper. So it's actually a fully playable game, right? And we'll go seeing the different bits and pieces as we progress through the session, and then we'll use those to compare against when we are on the talk. And yeah, of course, all the code would be available on GitHub, and I'll be sharing all the links then.
Right, but I guess the first point that I have to explain anyways is what are hooks. And I think the React docs do a really good work at explaining all this stuff, so I'll paraphrase that quite a lot. And the way I see hooks is a way to access all the lifecycle stuff that you would otherwise need a class component to work with, right? And when we look at hooks, the first thing that everyone thinks about is state, right? But we have a couple of other things that come with it, and we'll see them now in a bit. The other thing that the React team has been making quite an emphasis on is the fact that when we have a class component, we used to call them stateful components, and then we had a function component, and then we used to call it like stateless component. Well, with hooks, that won't be quite true because these function components will be able to hold state as well. So I guess the preferred terms right now are a class component and a function component, and that's it. The nice thing about it is that hooks and classes, will both coexist, so you'll be able to use them side by side. And that's another important point of it. Hooks right now are in an alpha, so essentially they are not shipped as a production feature by the React team, meaning that you should use them um, with a bit of a warning, I would say, in a way, because they may change. That's what the team says. Um, the they are expecting to ship them around the first quarter of 2019, so we should hopefully see them sometime soon in some 16 point something version, because they are actually not a breaking change at all, which is another really cool uh, you know mm, news for us here. So right, so before we actually get into what are the benefits of hooks and what they give us, let's see how do we actually get them on, right? So as we see here, they are inside an alpha. So the way we install the alpha is by doing something like, I'm using yarn, but you can use npm, it's the same for this. And we will need to install the next tags for React and React DOM. Now it's important that you install both, because otherwise you may find some funny issues like I found here. So I have a couple of examples of things that went wrong, under installation. They are all signs of the same thing at different stages, different mix of libraries. But what it means really is that you likely have either a mismatch of versions between React and React DOM, or maybe one of them is on the alpha, the other one is not, and so on and so forth. So if you see some of those errors, then that's probably what you're facing. Then here we have the versions themselves that we can use. So yeah, so when we have the versions, then uh, what we can do is start using them. So once we have hooks installed, we run the app and nothing really changes. And let's see actually how how we can actually use them before we go into into what they mean for the app and so on, and what would be probably the simplest example when we are transforming a component into it. So I have here the status logic component that provides the state essentially for the face here, that when we click it, it does this effect that I'm kind of pressing it in a way, right? So this is a typical component that is holding some state. So it has the component definition of a class, and then it defines what its state is, and then it defines a bunch of methods. Now in this case, they are on purpose like expanded. So this could be like a toggle that just changes, essentially when it's clicked, it just changes the state for one, or the other. But I did it like this, so it shows the concept, a bit of an easier way. And then we have a render method that just returns essentially the component, and it passes down all the methods. There are a couple of choices that we have to make when we make this component. One is, do we bind the methods, for instance, or maybe an alternative to this would be to say, well, I could just use the method in line, right? Now, alternative to that, we could also say that we could be defining the method like this, for instance, and then use the bind syntax for it. Or if we don't want to bind it there, we can bind it on the constructor. So we'll do something like this. So we can do, and then we can do this essentially. So there are all these different things that we already need to start thinking about when we do that. And that's one of the things that, in a way, as a side effect, in a way, hooks actually get rid of for us, right? Making certain decisions that at some point they could just make things a bit more complicated to think about them, in a way. Back to the original example that we had. Right, so how do we convert these into hooks, right? Well, the first thing that we said is that the first thing that we need is that the hooks that React is implementing work on functional components. So if we try to use a hook here, it wouldn't work. So first of all, what is the hook that we need in this scenario, right? Well, in this case, we are going to start with the simplest, which is use state, and it will allow us to hold state on hold the value of state in a way, and allow us to change it in a similar way that what we do here, right? So that hook is called use state, right, and is exported as part of the React package. And now the way we would use it would be something like use state on when we are rendering our component, right? But as I said before, this doesn't work on class components, so we'll need to do a bit of a refactor for that to work, right? And we leave that part towards the end. So by the way, if you try to do something like this, you'll likely get an error, I think, by React here, telling you that you can only call hooks within a function component. So when you see that, it's because you try to add hooks to a React component in that sense, right? Now, what is the state that we want to use anyways? Well, the state that we want to use is press, right? So for now, I'm going to say that, I'm going just to start like moving it on in a way, right? So the first thing we can say here is that we've moved the state to go within this container, right? Within this container of state for us. The API for state gives us two returns, like an array with two elements. The first one being the state, and the second one being a setter for that state, right? So the first thing we'll see is that this is gone now, right? And then we get our state, and then set state. So far, it's pretty similar to what we got before. The only difference is that set state won't be called with this.set state anymore. It will be just a function that we have accessible within the scope that we are working with. So if we look at these two, right? Well, they are pretty similar actually. So they are both calling this.set state, but we saw now that set state is within here, so we'll probably want to move it in, right? And now since we have them already in that format, we can probably just rephrase them like that, right? And now we have our methods within our render function here. Now, of course, this won't be anymore part of the instance of the component. They will be just part of the current scope. So we're almost there, right? We have our methods that would be then passed down to the UI, and we have our state and a way to set that state that we're seeing here. So now the next step is to convert this component back into a functional component. So for that, what we are going to do here is to convert it. So we are going to define a component that will take props as an argument, and will return, whatever it has, and then we, of course, don't need to forget to export it. So let's see if that works. Perfect. So we built our first hook. So the first thing we need to do is to change what our initial value would be. So instead of it being, is pressed and in an object shape, it will be just false, right? Which means that our state is not anymore like a state itself. This is actually just the value of is pressed, and that means that we need to change here so we can actually use the actual value. Now the next thing is that when we are setting state, we are not really setting an object anymore. We are just setting true in that case. So what does that actually mean? What are we really setting state? Well, not quite, right? We are setting is pressed. This syntax that we are seeing here is as deconstructing like an array, right? So we are picking up the first element and then the second element, and we can name those whatever we want. So now let's replace this for set is pressed. Let's try to reuse as much code as we can, and that's it, right? See if it worked. Beautiful. Now we could go further and take this further and actually say something like, well, we can just do something like that. And if we want to, we can even do this and directly inline the functions in here. There were lots of discussions on the React community around inlining functions and the fact that they get recreated on every render. That's true. The performance impact of recreating a function on every render is actually, for the most of it, negligible. We can actually just ignore it. If you are if you're concerned that this might be like a performance issue for your application, you can always use the, I think it is the use callback hook that allow us to keep a callback across renders, right? See actually if we have it here. So we can memorize essentially a callback that would change when certain properties change. So what that means in our example, if we want to keep this like that, right, we would actually keep what we had before, and then we would likely do something like this. And then we said that we need, to pass down when will it change. Right now, if we don't want it to, ever change because it doesn't matter, this is not really, something that matters all that much. We can just pass like an empty array as the second parameter of use callback, and we'll actually get like a function that never changes. Now, it's not entirely true. React may choose to actually re-render this function. But we get a better guarantee essentially that we'll get that function across renders for the most of it. But I would say that many times that's an optimization that you might not really care all that much about doing. So let's go back to what we had in here. All right, so one of the other things that we saw as a benefit for hooks is that we can use them to reuse logic, right? So how could we do that? That's probably one question in there. Well, one of the benefits or the motivations behind doing hooks was that they would allow us to share logic across components or encapsulate certain bits of logic so we can use them across different components. So how do we do it? Well, the first thing perhaps to bear in mind here is that hooks are just functions. So because they are just functions, we can extract them into other functions, and then with that we can reuse the code that we have. So let's see what that would look like, right? So imagine that we have this press hook, right, that we want to use, and we would like to get that out in a way out of our out so we can reuse it in some other parts of our code. So what would that look like, right? Well, the first thing that we need is to kind of get this out. So we can define a new function that we call it, in this case, usePressed. And it will be a function that takes no parameters, defines all this stuff, and returns potentially isPressed on mouse down and on mouse up. Now, how do we use it? Well, we can use it like this. Of course, we can save usePressed into another file, no problem at all. See if that still worked. So how does this work at all, right? Well, as I said before, this works because they're just functions. So essentially, React is coming to a component, looking at this function, running it, working out that there is a hook in here, and that's how it actually knows that it needs to use the state hook. And that's it, right? So now the nice thing about this is that when we look at our component in isolation, we are not leaking anything around the internals of these, pressed functionality in a way. We are encapsulating that within the, the hook itself. Now we can probably take that further, and since we are returning an object in here, what we could do is to say something like, this would be just pressed, right? And then we can deconstruct that within our component, and that's pretty much it, right? So essentially, all the logic for our pressed hook got encapsulated in there, and for the most of it, as a user of it, we don't need to worry about what it actually has inside. Now, say you wanted to do something else, and you want to extract something like or do something else on, for instance, on mouse down, right? Or on mouse up, something like that. How would you do it? Well, one way to do it would be this. We get our event handler in here. And we could say that now we can compose our calls. So essentially, pressed, we don't know if it needs, the event or not, because it is a mouse event handler. We will be passing just down the event here in this case. And the next thing that we can do here is just to do something else with it. So we could, for instance, alert, something like mouse up, right? So let's see if that works. There you go. So the interesting bit about hooks here is that they allow us to compose logic as well. So these could be another hook, for instance, that is dealing also with mouse up in that case. Now you might be wondering, if I'm using this hook as a shared piece of logic and I use it in another component, how does it know to essentially keep the state separate, right? How does it know that this piece of state belongs to this component and the other one belongs to the other component? Well, that's something that React does internally, and there are like a good few articles that are explaining how it goes about it, on its inside. You can also feel free to browse the code. I'll be sharing all these links in here. But the gist of it is that, in a way, when React is entering the rendering phase of the components, all these methods are being called, and essentially they are being called within the context of the current component that is working. So essentially, the state that you are defining here is associated with the component that is rendered and the instance of that component. And as a matter of fact, it's using the same mechanism that class components use as well to store it. So essentially, like they are sharing the same way to do it. And yeah, that's a way that React keeps track of it and how it can actually understand whether this is this particular component state or the others. Now that we've seen how the useState hook is used and how we use hooks in general, let's get into the next part, which is to handle hooks, like essentially deal with other types of hooks that we have in React, and some of those that allow us to tap into the lifecycle methods that we haven't done so far. So for those, we are going to see a bunch of them. They are useReducer, useContext, useEffect, and useRef. These are probably like the most important, I would say, ones that we have in React left. And we'll have a brief run through like what it means to implement each of them. But before we actually get into that, we probably need to see what the structure of the app is in here so we can make a bit more sense out of it. So this app at the top has like an app provider, which is like the whole logic for the game in a way. And it's providing a bunch of actions that allow us to manage this state. So essentially we have like all the different bits and pieces around the grid that we're playing with, and a couple of other informational bits like how many mines do we have left. So for instance, if I do this, I get 9 mines and so on. And then we have things like the mood essentially. So when I'm pressing something, the mood changes, and then it changes again. If something else happens, the status of the game, whether we are playing or we essentially like we have some kind of issue and so on. And then we have also like a timer that is counting up the seconds as we play. All of this is provided on this context in React, and then is consumed by the different bits and pieces, different views at different points. One thing that is also important to see here is before we implemented a hook in status logic, and this is also like important to see here because React in DevTools now added support for hooks. I'm going to reset it because every time there is a change, essentially the DevTools reset the open nodes in here. But here we can see the values of the different states, the different hooks that we use. And as you can see, this is named after the hook that we use. So it's called pressed, and then within that we have some state that is holding the value of false. All right, so now that we saw the overall structure of the application, let's see how can we turn that into hooks. So when we look at this app, we have a bunch of actions that are being passed down, right, apart from like some state bits, right? And the first thing that we can probably do when we look at these actions, right, is to try to understand what's going on within them. So when we reveal the cell, essentially when it's clicked, right, there are a couple of things that could happen, and there are a few things here that like have a mixed intent that we can probably express in a different way, when if we were to work with say lifecycle methods or in hooks, we'll see how that's actually easier to express as well. For instance, when we are about to start playing, we if we are on the start step in a way, we set plain, and then we go ahead and start an interval essentially that gets us into gets the timer running, essentially ticking. So that's probably the first thing that we could probably separate from here, and we'll see how we do it with hooks. And then when we go deeper into this method, it goes and checks whether we click the mine essentially, and if we did, then it tells us that we lost, and then it puts the avatar to be dead, and then if it's empty, it just reveals cells that are around it, and otherwise it just reveals that cell. And then it also does a couple of other checks to say whether did we win, for instance, and otherwise it just keeps at it, right? Now there are a couple of issues with this approach, and for the most of it is the complexity that it has, right? We see multiple calls to set state at different points in time. Some of them are even contradicting, because here we have like a mine essentially that has like the mood is set before when we have a mine, but then when we go down to this point, we probably want to set the mood again, because if we quit early, we won't be able to show the cells. So it gets a bit more complex when we look at it like that. So we can probably take a step back and say that when we're looking at our game's logic, we have a reveal action that needs to be called at some point, right? And then in a way, we know that we need to deal with it in some way that ideally the data would be, we would deal with it in somewhat an atomic way, we could say. Then there are a few other things that could happen, like we can reset things. Again, this has an effect on clearing the interval that was ticking away, changing the value. We could also switch the level. It has like an effect on resetting it, right? Again, another action. And tick itself, which is like an internal action that we have in here. And then we have a few others. One of those like placing a flag. And then when we get scared or get happy, which happens when we go here and say we press the cell, and then maybe we get out, right? Or we press the cell and we let it go, and then essentially like the state sets itself back to happy. So if you're familiar with Redux, we have a way to model those kind of things, right? So that they become a bit more easier to follow, I guess, and in the sense of like how we structure the data and how we deal with it from within the UI. And that's a reducer pattern. In React hooks, we also have reducers introduced, and as a matter of fact, reducers are the building blocks for useState, for the useState hook. useState is a specific case of a reducer. So how could we work with this as a reducer, right? How could we do that? Well, the first thing that we could do is try to identify the different actions that we have. And as we said before, in here, we would get like a reducer in a way, some state, an action, and then we would say, for instance, that we switch on the action type. When we go with something like place a flag, we do some stuff, right? And so on. Now the way we use that within our component is we import the useReducer hook, and then we go within, we can take what we have today on the state, bring that up, and again we put it within our render method. Now the second parameter that we get, we are not going to call it set state at this point. It's more like dispatching an action. That's really what it is. So we'll be calling that, passing in the reducer and setting the initial state in here. The first thing we can do is we can get rid of the constructor. We don't need that anymore. And then perhaps the next thing is that we would be defining our app provider in here as a regular component, right? For that. And then the next thing that we need is to declare these as variables. That would be probably the first step. So far we have all the actions calling setState as part of the class, but we said before that we're going to move all of those to a reducer pattern, right? So for that we probably want to like separate it and start like sort of defining actions in here instead of defining the full logic within our component in this case. So for that, maybe the thing that I want to do in here is to say something like dispatch type place flag, and then we can pass x and y as like the values that it needs to work with. And then we may want to just move this out. Now, interestingly, what we can do in here then, we can take it, and then what's cool about this is that we can actually like move all this logic away and potentially have it, within a method essentially that will allow us to place that. So that's what I'll do next. And this is going to take a grid, the mines, and the x and the y. Now we can get rid of state. And then we say probably something like this. We want to keep the previous state because otherwise it wouldn't merge it. And then right now we can call place flag state.grid state mines action x action y. And that's it. We've now moved place flag into its own method within a reducer. We can like test it separately and see what happens with it and so on. Now we could also think about place flag as a sub-reducer if we wanted to, and in that sense we could say that we could just pass the state from here and the action. So it takes the same type of configuration that a reducer would, and we take a state, but we care only about this and that, and then like we only care about x and y, and now we already know the type of action that we care about, so we could just leave it like that and not deal with it in any other way. So yeah, now that's place flag, right? So that's looking good. Now we can still have like certain logic here, like we would on our action creators or on our actions essentially in Redux, that can handle certain things. So for instance, here we say that if the status is lost, then we don't need to run this. So we can still leave that as that. Now we enter reveal, right? Now if we follow the same logic, we could say that we go here and dispatch the reveal action, and we pass it x, y as mine, and it's empty as part of the action. If we wanted to, we could say, we'll do the same. We call reveal with the current state and the action. But there are a couple of things that now we can't do, right? So essentially, where do we attach an interval? Where would we be, dealing with the interval? That's just not possible anymore, right? So we'll have to do that somehow. Now we don't know how, so we'll mark it as a to-do. Same thing with this, right? And anything that happens there. Now everything else we could say that we would be returning it in a way, right? As we wrap this up. If we are just about to start, we want to change the status to plain, right? That would be the initial thing, right? So now for that, we could probably just say, okay, well, status would be always in plain. So essentially, when we come in and reveal something, the first thing that we can assume is that our status would be on plain. So then what that means is that we can probably get rid of this for now. Now the status may change across our method. So essentially, when we go doing things to our grid, we might be getting something different. Now here we could also say that updated grid, because we are referencing state.grid, we can just call it grid, right? And now, at the end of our method, we can say that we'll be probably returning a new status. We will probably return the grid, and we'll probably be returning the mood. Now the mood, we could do some optimizations to this, so it only returns the things that it needs to, and so on and so forth. But for now, let's work with that simplification, and let's also start with like the mood that we could work with. And ideally, like when we reveal something, we would be happy. We can just kind of make that assumption. So then, what does it change? Well, like the first thing is that every set state, instead of like just setting the state like that, just goes and does something like this. And now here, right, we actually don't need to do anything, because we already had the default being happy, right? And if you had in mind the mood already changing here, so we don't need to do that. So we can remove that state as well. So that also means that our state became a bit simpler as well. And we have now this interval stuff that we need to somehow deal with in here, and we haven't done that yet. There's one thing pending though, which is how do we deal with the time, right? So before we said that essentially every time the status change from start to to plain in this case, we need to start ticking, right? We need to start counting the time. So now we need to react to a change in state and do something with it. That's what is called an effect, and that's what we can do with something like useEffect, right? Now before we would have done that by using, for instance, component did update or component did mount or one of those, and essentially at that point when something changed in our data, we would have done what we did. Or you could have used as well like the callback from set state to handle this. The problem with that approach is that it becomes a bit more complex to understand when that thing is happening and when it's not. So let's see how can we do that with this useState effect, right? So well, the first thing we can say is here, we can define a useEffect hook, and in this effect we can say that kind of what we had in here, right? So we want to define an interval that ticks, every second, and we only want to do that if the state is displaying. So that's the first thing. Now we had the tick here, so I'm going to re-enable that so we can use that in. But now there is a problem. Where do we store interval, right? Where do we keep track of this value? And the first thing you could say, well, I define it somewhere here, right? But what's going to happen then if we do that is that we are going to lose that value as the component gets re-rendered, right? So React gives us a way to do it, to keep track of these values, and it's called ref. So you may have seen refs in inputs, before, but now we can use refs to hold any type of value that we need. So for instance, what we can do now is to say that the interval is going to use a reference, right? And we don't need to specify which value it would hold at the beginning. And basically we're saying that in here we are setting then the current value of that interval. We are not setting the actual interval. So interval, when we use the useRef, we get access to a current value of it, and we can set it like that. And now the next thing of an effect is that we can return a function that will be like a cleanup function for this effect. So essentially, when that's done, and when something changes, we are going to run this function. And what we need to do here is to clear the interval. So it's something that we already had in other parts. Again, we need to use clear interval.current, right? So what happens is that then React will come along, call our effect, and either when it unmounts or when something changes, when this effect changes, essentially, it will call whatever cleanup function we have, which in this case is to clear the interval. Now it might be the case that we don't actually have an interval, right? So maybe we want to do something like if there is an interval, actually clean it up. Otherwise, don't worry about it. Now if we run this like that, the effect is going to run every time the app renders. So essentially, if we do it now, for instance, we actually don't see anything. Now when we start changing, something will happen, it will start ticking and so on. But if we actually were to put like here like a log, we would see that our effect run many times as we render the app essentially. So how can we avoid this effect? Sometimes can be like it's something that we probably don't want to do, because here we are always cleaning up the interval and then resetting it again so it keeps on ticking, right? But maybe we don't want that. So there is a second parameter that useEffect takes, which allow us to specify when this should actually change. And we are going to say that this will actually run when state.status changes. And now you can add many more like conditions in here, whatever you want. Right, so now let's reintroduce our log and let's see what happens. We can see that it runs on the first run, but now when we click something else that is not related to the status changing, it doesn't run. Now here we can follow and do something like this, and we'll see that it actually works like when the state changes, so start using it, and and so on and so forth. And now the interesting bit about it is that we don't need to worry about this anymore. So before we said that whenever we run reset, which is say like when you are for instance give it new, that effect will run directly. So we don't need to worry about having to do that again within our component. So the interesting part about it is that now the logic around the interval is kept all together in one place instead of in the multiple different places that we had it before. And now we can remove things like this. There's one more hook that is pretty useful, and it's called useContext, and it helps us reduce the artificial nesting that happens when we get here like multiple context consumers one next to each other. And let's see how we can use that, right? So the simplest way would be to do something like use context in React, and then from here you would import the context itself. Now the context is the full context exported, right? And then the way you access that within your component is you do something like what you're doing here, right? So use context, and that removes the need to have this. So this is when we have our models, and they still work in the same way. There is perhaps a better way to do this. Instead of exposing the whole context object, what you can do from within the app context, you can export another, which in this case is a method to use the whole app. And then we get a bit more of an idiomatic approach to describing what are we going to use in here. And we can do, of course, the same with the model. So all of a sudden, our component becomes easier to read. We have like a hierarchy that didn't exist in the first place, and now we don't have it anymore.